Hello. Today we're going to take a look at the procedure disjunction elimination. It's the next and really last of the proof procedures, right? You have introduction and elimination rules for everything except for disjunction elimination. And so we've got to fix that. Now, unfortunately, this one is the most involved of all the procedures that we've got. Reductio ad absurdum and conditional proof were a little different in that they involve making assumptions and as part of the procedure. Disjunction elimination is similar to that, but for disjunction elimination, you're going to have to make two assumptions in a very particular order. And so I don't want to say that this process is hard necessarily, but there are some things about it that just kind of make it a little trickier and a little harder to operate with, or a little bit more cumbersome, I should say, more sort of time consuming, and just it's certainly a more involved procedure, but ultimately it's the same thing as every other proof. What you're doing, you're trying to say, okay, what am I trying to do next? What do I have to get there? And and if that's going to create some intermediate goal, then I say, okay, great. Now I've got an intermediate goal, and how do I get that one? What do I have to work with, etc. Right? I mean, the process of a proof is always the process of a proof. So, without further ado, let's take a look at disjunction elimination. So here's the thought process behind it. Okay, and the thought process behind it comes down to a quotation by one of the most famous philosophers of all time, a man named Lawrence Peter Berra, otherwise better known as Yogi Berra. He was a catcher for the Yankees back in the day. But he was very famous for saying things like, "When you come to a fork in the road, take it," right? Or the game of baseball is 50% mental, or 90%. It was 90% mental. The other half is physical, right? Think about that for a second, etc. I mean, you just sort of go on and on and on about the number of these sort of malapropisms. And at one point, some reporter asked him about all of his sort of funny quotes that people attribute to him, and he says, "I never said half that stuff I said." And so it's a very standard Yogi Berra response. Anyway, the point is, when you come to a fork in the road, take it. Okay. And so if we look at this particular fork in the road, we got two alternatives. Okay. But when each of the two alternatives that we have just end up in the same place, it really doesn't make any difference which you pick. And the whole point of disjunction elimination is to try and prove that it doesn't make any difference which of two alternatives you pick. And so in this case, the case of this illustration here, we could refer to the right fork as the road to Atlanta and the left fork as the road to Atlanta. But like, look, they just both go to Atlanta. We would just call this the road to Atlanta. We don't have to worry about the left road to Atlanta or the right road to Atlanta. It's, they both get to the same place, right? And again, that's the basic idea behind the rule disjunction elimination. Remember, a disjunction gives you it tells you one of these two things is true. But if we can prove that whichever one of those things is true, something else would have to be, then we can just stop saying one thing or the other and just say that other thing that would have to be true in either case. And so disjunction elimination is going to work sort of this way. So when you have a disjunction on a line of the proof, and can end up with the same claim by assuming each of the disjuncts in turn, you can eliminate the disjunction and then replace it with the claim, right? So the idea is that if you have P or Q, and you prove that, look, if we assume P and we get R, and if we assume Q and get R, we can just stop saying P or Q and just say R, right? So instead of saying, oh, we have the left road and the right road, they both go to Atlanta, just call it the road to Atlanta. That's the idea. Now, of course, the thing that is sometimes a little tricky about this is that the claim can in fact be one of the disjuncts itself. Okay, so you might say we have the disjunction P or Q, and you want to prove that whichever one you assume you'll end up with P. Well, then you can stop saying P or Q and just say P instead. That sometimes happens in a proof. That claim can also be itself a disjunction, right? You can say, well, look, if we want to assume P or Q, and if you assume P, you get R wedge S, and if you assume Q, you get R wedge S. Well, then you can stop saying P or Q and just say R wedge S instead, right? Now, that's eliminating a disjunction in favor of a different one, but we still call it disjunction elimination in that case. I'm sorry. Like those are just wrinkles in the way it works that sometimes strike people as counterintuitive, but there's no reason they can't work that way. So again, here's the abstract view of what this looks like on a proof. And so the idea is that on some particular line, if you have a disjunction, you can start a disjunction elimination. You can't do disjunction elimination if you don't have a disjunction to eliminate, right? Just like you can't do a conjunction elimination if you don't have a conjunction, etc. You can't do modus ponens without your conditional. Again, a disjunction elimination requires a disjunction. So if you've got one on your proof, then you can use the disjunction elimination process to get probably what you want. So the idea is that we have a claim that says just A wedge B. One of two things is true, either A is true or B is true. Okay, and again, our assumption is we're just going to assume that. So our first step, okay, is to make an assumption, right? And we're going to assume A, and the reason we're saying it's an assumption. And again, you want to note a couple of things here over in the notes. Okay, so first thing you want to note is what for, right? Why are you making this assumption? Okay, and then the second thing is you want to say, is this the first half of this procedure or the second half? Because remember, a disjunction introduction involves two steps. It involves two different assumptions, one made and then the other immediately after. All right, so our first assumption is A because it's the first disjunct. We're going to assume the first disjunct. So we're going to assume A, and the idea is we're going to note over here that we want to get C out of it. So if you can assume A and then through some process get C, okay, then you can immediately discharge the assumption that you made here on line 2, and then immediately assume the other disjunct. Okay, so that's B here. And again, this is an assumption. Okay, and it's assumption for disjunction elimination. It's the second half of that assumption. We already assumed the first part and got what we wanted. And so now we're assuming the second part of the disjunction to see if we can still get what we want. So if through some process you then can get C, right, you've proven that when you assume A, you get C. And then when you assume B, you get C. So you can just eliminate the disjunction and just say C. The way you cite that is you say, you put the line on which you had the original disjunction, the line on which you assumed the one disjunct, and then the line on which you got your result, and then the line on which, it'll be the very next line, that you assumed the other disjunct, then the line on which you got your result, right? And then of course, you actually don't need this one. I don't know why that's in there. And then you could just cite disjunction elimination because that's the line that this is itself on. Okay, so the idea is assume A and get C, then assume B and get C. Then you can just say C and say, look, when we assumed A, we got C. When we assumed B, we got C, and that's disjunction elimination. You have eliminated the disjunction A wedge B in favor of the claim C. That's the abstract way of how it works. Here are some more concrete examples. So what we're going to show here is that if Q then R entails P or Q, if P or Q, then P or R. Okay, and so again, we've started with our given. That's our claim. That's why we're allowed to say it. It depends only on itself, etc. And so see here, it's already been highlighted in red, but I'll circle it in red too here. Okay, look, that's a conditional. Okay, so if we're trying to prove a conditional, there's only one way to go about that. And it's even in the language, right? Again, philosophers are generally pretty good at naming things. So if we want to prove a conditional, we're going to have to use the process known as conditional proof. So that's going to have to be the first step here. So what you want to do is you'll want to assume the antecedent. Okay, see, this is the antecedent, right? And so we're going to assume it. And again, we're going to keep track. When we make an assumption, you should always remind yourself, why are you doing it? Okay, so if it's for conditional proof, then that means that this is the consequent you're looking for. That's the thing right here. And so that means that, that's what you're looking for. So notice we have a disjunction here, and what we're looking for is a different disjunction. So this is going to be one of those times we're going to try disjunction elimination. We're going to try and eliminate this disjunction in favor of this one. Okay, and so now it's off to start that process. Okay, so we have the claim P, remember, because P is the first disjunct here, okay, and that's an assumption, and it's an assumption for disjunction elimination. And again, this is note to yourself, this is the first of two assumptions we're going to have to make. And I've even highlighted in red. I'll underline it in red. That's our goal, right? We want to be able to derive P or R. Now, do you see any way of deriving P or R from assuming P? Right? This one should be pretty much automatic. It's just disjunction introduction. If P is true, then P or whatever is true, and that includes R. And so just take line 3 and disjunction introduction. So now here's a couple of things happen immediately. First off, the assumption that you made on line 3, the assumption P, that gets discharged because you assumed P. That's the first half of the disjunction, and you got your goal, P wedge R. Okay, and so now you can simply go on to assuming the second part of the disjunction, this Q here. And so on the next line there, that's line 5, you make an assumption, you assume Q, and you note why you're doing it. You're assuming that this is the second part of our disjunction elimination. We assumed the first part of our disjunction and got the thing we wanted. Now we're assuming the second part of our disjunction, and we also need the thing we also want, P wedge R. Okay, you have to get the same thing. And so if you have a Q, again, think now I need an R, right? So that I can get, R wedge P, right? Or P wedge R essentially. And that's, if you're just looking at what you have to work with here, notice this line 3 and line 4, because they both sort of depended on line 3, are both kind of out of the question, right? Those are out of bounds because we've discharged that assumption. Okay. And so if you'll notice here on line 1, you have a conditional, and line 5, you have the antecedent of that conditional, and the consequent is something that we want. It's R. Because if we have R, we can get P wedge R. Just like if we have P, we can get P wedge R. Okay, and that's what we're going to do. Right, we're going to use line 1 and line 5 modus ponens, again, remembering to fill in our dependency numerals correctly. And, once we have R, it's disjunction introduction to get us P wedge R. Right, because if R is true, R or whatever is true, or whatever or R is true. And then from there, notice this second assumption discharges immediately, okay? And we can sort of, conclude P wedge R. And so what we do is we cite the line on which we have our initial disjunction, the thing that we eliminated. We have the line on which we assumed the first half of that disjunction, the line on which we got our target, the line on which we assumed the second half of our disjunction, Q, the line on which we got our target, line 7, and then top it off with the rule disjunction elimination. So it's more involved. It involves 5 separate line citations, but again, that's just the procedure. That's just how it works. It's not in any way inherently difficult. It's just a set of rules, right? It's just a set of procedures. Computers can do this and they can't think at all. So, so here we go. That's pretty much it. But now we have to finish out the proof, because remember, the whole point was we wanted to be able to prove this. We wanted to be able to prove this conditional statement up here. So we finish off our conditional proof, and we say, look, we assumed P wedge Q, and we got P wedge R, right, which is right here. And so we can then conclude that if P wedge Q, then P wedge R, and then we can stop assuming the assumption that we made at line 2. We can discharge that. And once that's discharged, then the only thing we're left with a dependency is this last line. It depends on 1, but that's okay because 1 is given, and proof's done. All right. Let's do one more. Right. So this one is going to be a little bit more involved, a little bit longer. Because here we have like just disjunctions, right? And so that's going to give us a sense in which that tends to take a lot of the thinking out of this process, right? If all you got are disjunctions, you're going to be using disjunction introduction and disjunction elimination. Those are your choices. Now you could use, I guess, a reductio in there if you really wanted, but it's not going to make anything neater or tidier. Again, the only operator used is the disjunction, okay? So again, we could make things messier by using negation introduction, but again, why, right? All we have are disjunctions to deal with. So yeah, you want to eliminate some and introduce others. Great. Okay, so here's how it goes. And you're like, oh man, that's going to be a long one already because I've given myself lots of lines. Well, maybe it won't be that long. Maybe it will. Who knows? I know, but yeah, okay. All right, so again, highlighted in red here, we have the statement that we're, we got to put that on the proof. That goes on there. It's a given. Right? And so we're trying to show that P or Q or R means the same thing as Q or P or R, which intuitively it must, right? So this proof has got to come out, okay? It's got to come out right, because of course that must be true. And so again, notice that the thing that we're trying to prove is a disjunction, okay? And so as such, what we want to do is we want to use the disjunction that we have, the one that we're starting with, and we want to be able to, to prove P wedge, Q wedge P wedge R. And so what we're going to do is we're going to assume the first half of this disjunction, and we're going to have this disjunction here as our target. Okay, and again, we want to tell us, why are you making the assumption? Well, this is the first half of a disjunction elimination. Okay, so notice if we have P, then we have P wedge R, which is part of our disjunction. That's all we needed. So we just simply added on. If P is true, then P or whatever is true. Okay, that's going to be disjunction introduction. And again, fill out the dependency numerals correctly. And of course, if we have this part of our disjunction overall, notice that this is the one we wanted. If P wedge R is true, then P wedge R or whatever is true. And so we can just, again, use disjunction introduction again. Boy, that was easy, okay? And so that's really all we need. And of course, now we discharge that assumption we made it to, right? We assumed the first half of our disjunction and we got our target. Now we immediately want to assume the second half of our disjunction and then get our target again. And again, make a note to yourself, right? This is for disjunction elimination, and it's the second of two parts. And again, our target's the same. We have to prove the same thing. So if we assume Q wedge R, which is the second half of this disjunction up here, and what we want is to get Q wedge P wedge R. Okay. Well, take a look at this for a second and think, my goodness, what do we have to do now? Well, the correct answer is that, look, we have a disjunction here, right? And so if you have that, you can use disjunction elimination, right, to turn it into our target. And so essentially we're doing a disjunction elimination within a disjunction elimination, which is fine. Sometimes you'll do conditional proofs inside of conditional proofs, or RAAs inside of RAAs, or some combination of those several things. All right, so our first assumption, okay, is that we're gonna take this disjunction here. We're gonna assume the first half of it, and then we're gonna try and get again our target, Q wedge P wedge R. Notice if Q is true, then Q wedge whatever is true. So Q wedge P wedge R is a pretty easy target from there. Okay, and so seeing this ahead of time helps you know that that's the right thing to do. You say, okay, look, if I do disjunction elimination, that means I'm going to have to assume Q and then get Q wedge P wedge R. And you say, oh, well, that'd be easy. And then I'm going to have to assume R and then Q wedge P wedge R, which, again, that seems pretty easy. We've already done something very much like it. So I think, okay, I'll be able to get where I need to get by doing that. Okay, so when you assume Q, you get Q wedge P wedge R pretty much in one step. You discharge that assumption. You stop assuming Q, and instead we want to start assuming R. Right, because that's the other half of our disjunction that we're trying to eliminate. So here we get the next line here, which is our remember, this is the disjunction that we're trying to eliminate. We already assumed the first half of it. Okay, now we want to assume the second half of it down here. All right, and again, note why this is the second of two. Okay, this was the first one. And again, our target is Q wedge P wedge R. And so if you have R, okay, then you know that R or whatever is going to be true. And so on the next line, you just use disjunction introduction to add P wedge R to R. And then on the next line, if P wedge R is true, then P wedge R wedge whatever is going to be true. And so again, we have Q wedge P wedge R, and that gives us our target again. So whether we assumed Q or whether we assumed R, we got Q wedge P wedge R. And so that proves that we can eliminate Q wedge R in favor of this longer if Q or Q wedge P wedge R. Okay. So again, that second assumption discharges, okay, because we got what we wanted out of that. And so then what we're going to do is we're going to sort of, we're going to discharge the assumption at 5, actually, because what we're doing here is we're going to conclude Q wedge P wedge R. Okay, and again, we want to say, like, look, here's where we had our disjunction, okay, and here's where we made assumed the first half of it. Here's where we got our result. Here's where we assumed the second half. Here's where we got our result, and we used disjunction elimination, okay. And that discharge that is going to essentially replace, right, because remember, when we completed this disjunction elimination, when we eliminated Q wedge R, okay, what we did was we then finally completed this second part of this disjunction elimination by getting Q wedge P wedge R. And so we get to write Q wedge P wedge R again, okay, because remember, the whole point is that, again, this still sort of depended on line 5, but of course after this line, the 5 is going to be discharging, and so we won't be able to use it for anything. So we say here Q wedge P wedge R, again citing line 1, which was the first disjunction that we started with. That's our given, okay? And line 2 is where we assumed the first half of that disjunction, which is here. And then line 4 is where we got our result, okay? Got the goal here, Q wedge P wedge R. And then line 5, we assumed the other half of our disjunction, and it was all the way down to 11 using another disjunction elimination that we got our result, Q wedge P wedge R. And then, that finally allows us to replace the disjunction on line 1 with all of this stuff. And so line 1 still stays here because it was part of what line 1 itself depended on. And then that's that. Right, so then we have proven. So in this particular proof, used 2 instances of disjunction elimination, and one of them was used for the second half of the first one. Right, so if you want to go back over that, take a good look at it, sort of follow step by step, then try and do one of these on your own. It's never enough just to sort of watch. Definitely take good time on the practice and really sort of turn it over in your head. And again, just think of it as a procedure. Right? When you have a disjunction, you assume the first half and get what you wanted, assume the second half, get the thing you wanted, and then you're done. And then you just use the rules and cite the line numbers that are necessary, and that's how that works. That's disjunction elimination. And now you have an entire complete proof set. You can now prove anything that it is possible to prove in S.